Good afternoon. This video is for 7th grade science. Today I'm conducting an experiment about the 3 transfers of thermal energy. Thermal energy has to do with the molecules that are in the matter of any type of substance, object, solid, liquid, or gas, in which the molecules are in motion, which is by definition kinetic energy, and how they respond with temperature changes, and things of that nature. So what I did earlier today is I modeled conduction. I should probably back up and say the 3 transfers of thermal energy, heat energy, are conduction, convection, and radiation. Maybe you've listened to the song that I posted that was done by a science teacher that I don't even know, Mr. Parr. And he did his catchy little transfers of thermal energy to the sound of Imagine Dragons. So it's catchy, it is effective, and so hopefully maybe you're familiar with the words that I'm using to you today in this lab demonstration. Before moving on, also I'd like to mention that I did share this lab in STEMscopes. So I will take a picture of my data tables, and you will see, at least through video, what it looks like if we would have conducted it in the lab like this week if you're at school. So conduction I already did this morning. I did have on my safety goggles. Obviously my hair is already back because it's the new do. And I just simply have 2 cans. They call this the aluminum bridge. I just wrapped this around my metric ruler and made what they call in the lab handout an aluminum bridge. It's aluminum foil. And then I placed a piece of orthodontics wax at 3 centimeter mark, an 8 centimeter mark, and a 13 centimeter mark. And you can see where my finger is pointing. The wax is actually still there. Heat source is here at the 3 centimeter mark. And you can tell that if I move this, you can tell that they are, here's my 3 centimeter mark and here's my 8 centimeter mark. Those are gone. You can kind of see the shadowed area. I tilt that. There it is. It's right here. This is where the wax is melted, in here. So on my data table for conduction, I had 24 seconds for the 3 centimeter piece of orthodontic wax to melt. Then I had 58 seconds, about double. And then, as you can see, it's still here at the 13 centimeter mark. It did not actually melt completely, but the wax became more transparent. It's translucent, obviously, right now. It's foggy. And I've told you before in class that transparent would be like looking through the bulb. This is called a radiometer, or your window. When you look out your window, that would be transparent. So that took 4 minutes and 45 seconds is when I finally decided. I could have said 2 minutes. I, of course, was multitasking and doing some other things around my lab table. So I had my stopwatch, obviously, to record those times in seconds and in minutes. All right, so that's conduction. Conduction, obviously, different from convection and radiation. Conduction is things they're touching. Okay, so textbook definition, to get a clue of what's going on here, is the wax is sitting on the paper, and that on the aluminum foil, and that is being given a heat source. Now, the flame is not actually touching the aluminum foil, but the heat, again, that thermal energy is being transferred. The heat is being transferred to the aluminum foil, and we call that conduction. So it's through a medium, whether it be a solid, a liquid, or a gas, that thermal energy is being transferred through a medium. So textbook definition, if I look at our vocabulary handout, transport of thermal energy that can occur in solids, liquids, and gases when 2 substances of different temperatures touch. Boiling your macaroni and cheese. I am in no doubt that you guys have been making some lunch for yourselves in these past few weeks. So that's conduction. We're going to move away from that. I'm going to actually move that out of the way. And the next demonstration, I'm going to demonstrate convection. That's sitting right here in front of us. Lava lamp. Okay, this is actually our lava lamp from school. And what I want you to do is just kind of take a piece. Here comes a blob. And so what I've done on my data table, this is modeling convection. And what I've done is I've tried very hard to take a picture of my lava lamp. I'm not an artist. And the blob moves away. Here's a really big piece of the lava lamp blob, the material, and it separates. This is my heat source, and it's separating and it's moving towards the top. And then it's going to cool, right? It's going to cool, and it's going to make itself back down to the heat source. And we know the way that a lava lamp works, but it's an excellent example of convection. And that's actually the picture that is in our vocabulary, if I would share that like I normally do in classroom, is a picture of a lava lamp. So if you're following along with this, and you'd like to write this stuff down, all you do is draw a lava lamp and label your heat source here. Label your blob here and here. And again, there's a temperature difference that's giving it motion and making it move. And so that's what I wrote here was the heat source. The temperature of the blob is hotter and it decreases. And so then I put a temperature and an arrow down at the top. So textbook definition, heat transfer again, caused by the rising of hotter, less dense fluids and the falling of cooler, more dense fluids. Okay. All right. So that is part 2. Part 3 includes a radiometer. Okay. This is going to show us radiation, the last type of thermal energy transfer, radiation. And radiation just simply is a heat source that travels through waves. The sun. The sun is an excellent example. And again, as it warms again this week, you can feel that. You can go outside and you can feel the sun on your face. So how we're going to model the sun today to get our radiometer to move is the heat, the radiation that's going to come from my light bulb that's in a clamp lamp. And we're going to heat up this bulb. There's some veins on the inside of it, and soon you're going to see them move. That heat is going to transfer to this radiometer, and it's going to measure. It doesn't necessarily tick or do any type of numbers on the bottom of it, but we're going to take the temperature from a difference. So that's how my data table is set up. I have right now, I'm using my metric ruler, and I have it at 20 centimeters. I moved it, so. And then I'm going to move it forward. You may see the veins on them speed up because it's getting hotter, right? If I had you, obviously I would have you predict what's going to happen to the temperature as we move the radiometer closer to the sun, closer to the incandescent light bulb, right? So I'm just going to model that for you, and this is going to get really bright, right? Can you already tell it's working? Pretty cool. I'm sad that we're not going to be able to use these because obviously I have ordered enough for our lab teams to use those. So again, textbook definition, radiation is probably one of the easiest ones to remember, is the transfer of energy on waves, just like the sun. All right, it looks like we have a really good speed going here. So I need a beginning temperature at, okay. So our beginning temperature we're going to do, this is science, so we're going to take this in centimeters. Looks to me like I'm at 26 degrees Celsius. Okay, so I'm going to put this up here. All right, I'm at 20 centimeters, so I'm going to hold this here for 3 minutes. I gotta find my stopwatch. Go. Obviously, again, as we're waiting, I would be prompting you with making predictions, because that's what we do. And obviously, I mean, they're not hard questions, right? But we're going to compare these different values at different distances. So it's good for you to understand that obviously the temperature is going to increase from my initial beginning temperature. see what my stopwatch says. I don't lose track of time. Okay. Another part of our data table is, did the veins move? And obviously they are. Again, this is going to become absolutely boring and unnecessary. All I'm going to do is finish this lab, and then I'll take a picture of my data table like I did last time. And maybe I haven't done a lab for you guys yet. So anyway, I'll take a picture of this because I'm not going to have you sit here and watch me for another 6 minutes. I'm going to move the radiometer closer to our light source, and I will get this data in the data table. I'll take a picture of it, and I'll also post this video. After I collect that data, it is important to note that to see this relationship, the best way to do that is to construct a graph. You'll see that. Okay, so what I did is I put the distance along the x-axis, the horizontal axis, and up down here I have a degree Celsius. I put the temperature on the y-axis or the vertical axis, and I will, I will post that also in Classroom. All right, I'm at 2 minutes, so like I said, this is going to become very boring. I am already up to 33 degrees Celsius. So I'm going to say goodbye for now. I'm going to finish my lab. I have about 40 seconds left of this measurement. I'm going to do 2 more, and then I will post the information in Classroom. You guys have a great afternoon.